All right, let's practice some differentiation. Review some of these rules that we learned in Calc 1. First of all, number 1, f of x equals pi squared. Pi is a constant, and so pi squared is also a constant. So we use this first rule up here, and we get that the derivative is 0. So not too much work to do for that one. For number 2, s of p is square root of p minus 1 over p squared. We can rewrite that as, well, square root of p is p to the 1/2, and 1 over p squared is p to the -2. And so we just have a couple powers of p, and for that we can use the power rule, which is right here. That has a variable of x instead of p, but it works the same way. And so I will write that s prime of p, we just bring the exponent out front, 1/2 p, and then subtract 1 from the exponent, so we get -1/2. And when we bring the exponent out front here, we get -2. And when we subtract 1 from it, we get -3. And so we can just clean that up a little bit to arrive at 1 over 2, and then p to the -1/2 is sort of 1 over square root of p. So I'll put that in the denominator. And then minus a -2 would be plus 2, and p to the -3 gives us a p cubed in the denominator. So that's a nicer way to write the answer. Number 3, we have fraction t minus 3 over t plus 3, the rational function. And we can use the quotient rule for that, which is right here. And I like to remember this as low d high minus high d low over low squared, where low is the denominator of the original fraction and high is the numerator. So, well, let's see. So we have f prime of t is equal to low, which is t plus 3, and then d high. So let me just write that I'm going to take the derivative of that. I'll take it in a moment. And then minus high and d low, all divided by low squared. And now let's take those derivatives. We get t plus 3 times just 1 minus 0, right? So that just goes away. It's just 1. So it's this times 1 minus t minus 3, and then this derivative is also 1. So I could write times 1 here, or I can just leave it like that. And we're still over t plus 3 squared. And if we simplify the numerator, we have a t minus t, right? Oh, maybe I should just write this out. So t plus 3, and then I have to distribute this minus sign, so I get minus t, and then minus a -3 is plus 3. Okay, and so t minus t cancels out, and I just have 3 plus 3 is 6. So my answer is going to be 6 over t plus 3 squared. Okay. And my problem 4 has migrated. Let me try and knock it back down. Okay, that should work. And this is a composition of functions, right? I have an inside function, and then the outside function, the square root. And for that, we need the chain rule, which this is one way to write it out, right? The g is the inside function and f is the outside function. And if you want to take the derivative of that whole thing, then you do the derivative of the outside, evaluate it at the inside, times the derivative of the inside. So let's give that a try. Well, first of all, it might be helpful to rewrite this as 5x cubed plus 2x, and then the square root is the 1/2 power, right? So now we can apply the chain rule, and we get that the derivative of the outside, you want to just sort of think of the inside as a block or as sort of a variable. So it's just this circle to to the 1/2, and the derivative of that is 1/2 times what's in that circle to the negative 1/2. And now we multiply that by the derivative of the inside of what's in the circle, which is 15x squared plus 2. So that's it. That's the derivative. We can just clean it up a little bit. This expression to the negative 1/2, the minus sign puts in the denominator, and the 1/2 makes it a square root. So we can make a fraction, and we have the 2 in the denominator, and then we have this square root of 5x cubed plus 2x. And then the only thing left in the numerator is this expression at the end here, this factor, 15x squared plus 2. That's our answer. Now we'll head over to the right here, number 5, g of theta equals cos squared theta. Remember that this is a shorthand for cosine of theta squared. All right, so it's a composition again. We have an inside function and an outside function. We can use the chain rule. So let's give it a try. G prime of theta. So again, we have sort of the inside thing squared. The derivative of that's going to be 2 times the inside function to the 1. You don't have to write that, of course. It's a 1, not a prime. Maybe I should make that clear. And then times the derivative of the inside, derivative of cosine theta, which is negative sine theta. Okay. So you put that all together, you have negative 2 sine theta cosine theta. And, well, 2 sine theta cosine theta is the same thing as sine of 2 theta. That's one of those trig identities. So that's a nice way to write the answer. And here we have another composition, but this time the square is not on the trig name, so I don't have to rewrite it. It's actually just the theta squared is the inside function this time, and the secant is the outside function. So chain rule again. Derivative of secant. Do I remember that one? I think it's secant tangent. It's been a little while. So secant of the inside times tangent of the inside. Don't be afraid to put the theta squared in both places there. And then times the derivative of the inside. So just times 2 theta. And that's it. That's the answer. Now let's just practice using the derivative to find the equation for a tangent line to a curve. And the first step of this problem is to find the derivative of the function. Okay, just like we've been doing above. So looks like we have a product of 1 plus x times cosine x. So we need to use the product rule, which was up there somewhere. And there it is. That's one way of writing it. I think the way I typically did this in Calc 1 was just to write the original function twice with a plus sign in the middle. And then the first time I'll take the derivative of the first thing, and then the second time I'll take the derivative of the second thing of cosine. Okay, so derivative of this is just 0 plus 1, so it's 1. So that is just 1 times cosine x. And then I have the 1 plus x, and the derivative of cosine is negative sine x. So there's my derivative. And that's going to give me the slope of the tangent line, right? But it kind of gives me the slopes of all the tangent lines to the graph. But I only want the tangent line at this particular point. Okay. And the 0 here is the x-coordinate of the point. So I want to know what y prime is when I evaluate it at x equals 0. Okay, so let's just plug in 0. So it's going to be cosine of 0 plus 1 minus 0 is 1. And then I have a negative sine of, oops, that was not supposed to be theta back there. I'm so used to writing thetas. All right, how am I going to? Okay, so cosine theta. And I get my pen back. All right, plus 1, and then we have a negative sign of 0 as well. And cosine theta is 1, sine 0 is 0, so we get an exciting answer of 1 for the slope of the tangent line. All right. And then if you remember your point and slope form for the equation of a line, it's y minus y naught equals m times x minus x naught, where x naught, y naught is any point on the line, for example 0, 1, and m is the slope, which we just found to be 1. So we just replace those three letters by their values. Y minus y naught is 1, slope m is 1, x naught is 0, and we get y minus 1 equals x, right? Or if I add 1 to both sides, I get y equals x plus 1 for the tangent line to that curve at the point 0, 1. Okay, and one last problem. h of theta is theta times sine theta. Find the second derivative of h at pi over 6. Oh goodness. All right, so we've got to take the derivative twice, and it's going to be product rule that's involved here. So h prime of theta will have the derivative of theta, which is 1, times sine theta plus theta times the derivative of sine theta, which is cosine theta. So there's my first derivative. And now I'm going to take another one. Take the derivative of that to get h double prime, to get the second derivative. Okay, so the derivative of sine theta is cosine theta, and then I have to use another product rule for this term. So the derivative of theta is 1, and then that's times cosine theta, and then plus theta times derivative of cosine theta, which is negative sine theta. And let me just simplify that a little bit. Cos theta plus cos theta is 2 times cos theta, and I have a minus theta sine theta. Okay, so that's the second derivative function. Now the problem's asking me for the value of that at pi over 6. So we just have to plug in pi over 6 for theta. So we get 2 times cos pi over 6 minus pi over 6 times sine pi over 6. And now we got to remember those values of trig functions. Let's see, do I remember these? Pi over 6 is 30 degrees. And so I suppose that cosine of 30 should be root 3 over 2. And sine of 30 degrees should be 1/2. And if you don't have a good way of memorizing those, then I will show you one in a few days that helps me remember them. Okay, so can we simplify this a little bit? Cancel some 2's here to get a root 3. And multiply these fractions to get minus pi over 12. There we go. So I hope that that was some useful review for you. If you need any help with remembering how to use these various derivative rules, please do come by my office or the Math Center or wherever you like, and I'll be very happy to go over some more examples with you and make sure you got this stuff down, because while derivatives are not going to be sort of the main focus of this course, we are going to be using them a lot. So it'd be good to feel real confident with them so you don't have to think about them a whole lot, and then you can really focus on the new material. All right, I will see you in class.